Hello again. I just want to take a look at some of these questions that you guys commented on that you thought were the most difficult. There's 4 questions in this set of questions from number 11 to 20 that seem to have been the most difficult. So I'm just going to take some time to explain them. The first one I want to look at is number 12. The big thing to understand here is what this problem is really telling us. These numbers up here represent the number of students in each activity. And these numbers right here in this matrix represent the percentage of kids that are going to earn awards in that activity. So in tennis, you see 0.3. Remember that 0.3 is equivalent to 30%. So what it's saying is that 30% of these kids in tennis are going to earn an award. And so on, 40% in soccer, 20% in cross country, and 5% in football. It says, given these matrices, what's the estimate for the total number of sports awards that will be earned for all of these? So what we have to do here is we just have to figure out what is 30% of 40. In order to do that, we're going to take 40 times the 30% in decimal form that are going to earn awards, plus the students earning awards in soccer, which would be 40% of 60. So we're going to take the 60 total, and 40% of them are going to earn awards, plus cross country, 80 total, and 20% are going to earn awards, plus 80 total again in football. And in this case, 50% are going to earn awards. So remember that when doing any problems with percents, we always want to use the decimal form, okay? It's impossible to multiply or divide or add or subtract an actual percent. So we're better off using the decimal form when doing calculations. So most of the time on your ACT, I'm guessing that you will want to use decimal forms of percents, and that's what we used here and here and here and here. Thankfully, in this chart, that's what was given to us. If you would calculate this, you could type this all in at once. Your calculator knows to multiply before it adds. So we don't have to type this in a bunch of different steps. You can type this all in at once, and you'll see that this total is equal to 92. So out of all these students in sports, 92 are earning awards. Next question I want to look at is number 14. This problem actually pertains to the chart on number 13. We'll just take a look at the question first and then see what's happening there. So what this problem says is it says we own 2 sets of 30 calculators each. So the first set has 30 calculators, and the second set has 30 calculators. Due to destructive children like yourselves, 2 of these calculators are destroyed, and 6 of these calculators are destroyed. So what we have here is our first set of calculators is only going to be 28, and our second set is now only going to be 24 calculators. It doesn't tell us which of these sets are in which class or anything like that. So what I would guess I would look at here is that the total number of calculators we have, if we added these up, is 52. That's kind of the quick shortcut here to see. Total calculators we have is 52. So if I go back and look at this chart, we're looking for which periods would have too many students for calculators. So basically, which periods have more students than 52. If we go back to this, period 1, there's only 1 class offered period 1, and there's only 21 students. So period 1 is just fine. Period 2 has 24 students in 1 class and 22 in another class, both period 2. But 24 and 22 are not an issue for the 52 calculators we have, so period 2 is fine. Period 3, 2 sections, period 3, we have 23 students in 1, 25 in another. Both of those numbers would be fine for our calculator sets. So period 3 is also okay. We could use our set of 28 calculators here, set of 24 calculators here, or vice versa, excuse me, 24 here, 28 here, and we'd be just fine. The only issue that it comes up is period 4. Period 4, we have 2 large classes, a class of 29 and a class of 28. That's definitely going to be impossible to use with those sets of calculators we have after we take out the ones that were destroyed of 28 and 24. So these 2 numbers are going to be an issue for these numbers of students. So going back to the question, the only period that we're going to have an issue where there's not going to be enough calculators is period 4. Next one I want to take a look at here is number 15. This might actually be my favorite question we've done so far. just because I actually found myself thinking much harder than I needed to think to complete this. It asks what expression must be in the center here so that all rows, columns, and diagonals like tic-tac-toe are equivalent. Well, all you really have to do is look at one of those completed rows or columns. If I look at this completed row and I add all of these up, I have 1x and 8x and negative 3x. So 1x plus 8x plus negative 3x. If I add those up, that would be 9 minus 3 is 6x. So all of these rows and columns, whether we're going up and down or across or at a diagonal, have to be 6x. So if I erase some of that mess I just made, I can see that in order for this to be 6x, what do we have to have in here? Well, it's pretty easy to see that if I have 6x right here, I want these two to add up to 0. So the center has to be 2x. You could use any different combination. You could look at this right here. You could say 7x plus what minus 3x has to equal 6x. And in this case, you have 7x minus 3x is 4x. So 4x plus what additional empty spot would equal 6x? Answer, 2x. Great question. The last question I want to look at is number 20. This is also one that you asked or mentioned might have been difficult or challenging. On this question, it's just asking what algebraically is equivalent to x divided by y. The thing to remember here is when you have x divided by y, we just got to remember that what we do to the top, we must do to the bottom. If we divided by both or multiplied by both, that isn't going to change the value of this. So if we look at these, option A is the correct answer. On option A, they multiplied both the top and the bottom by z. Well, multiplying the top and bottom by z is just like taking this expression and multiplying by 1. Anything divided by itself is 1. If you multiply by 1, it doesn't really change it. So you're still going to get xy, and therefore it's going to be equivalent. So multiplying by z, top and bottom is the correct answer. A is the best option here. Notice here they multiplied the top by x, the bottom by y. That would not be equivalent to 1, so that would not be valid. Here we have x over y. They multiplied the top by y, bottom by x. Again, not equivalent to 1. You cannot subtract the same value on top and bottom, and you cannot add the same value on top and bottom. That does not work. For these two options, just think of having 1/2. If I subtract 1 on top, subtract 1 on bottom, I would have 0 over 1, which is 0. 0 is not the same as 1/2. So we can't add and subtract the same on bottom. That does not work out. Best answer, A.